in this work example question, we'll be going over paper 1 question. It comes from the 2019 administration, the summer administration of ACE Physics paper 11. This is question number 20. It deals with Hooke's law. The learning objective: describe the behavior of springs and use Hooke's law. It says a spring of original length 100 millimeters is compressed by a force. The graph shows the variation of the compressing force F with the length L of the spring. And we're trying to answer what is the energy stored in the spring when the length is 70 millimeters. A moment ago that we discussed that force times displacement, in this case it's given as a length, that's what work is, right? Work is force times displacement, and work is energy. And so this is an area problem where we're multiplying force times length, and because the force varies, right? So from 0 up to 6 newtons of force, that's what gives us a 70 millimeter new length of the spring, right? So the compression is actually the difference between 170 millimeters. So the area that we're taking is the area of a triangle, 1/2 base times height, where the base here is the change in length. And so 100 millimeters minus 70 millimeters is 30 millimeters. Now is a good time to remind ourselves that a very useful way to make sense of metric conversions is to just know what order of 10 they represent. So if we know that milli is the same thing as 10 to the negative 3, then I can just easily convert 30 millimeters into meters by using this order of 10. It's not technically correct scientific notation where the decimal isn't after the first digit here, but it's really understood to be here right now. But if you're going to use a calculator anyway, which you are permitted to use on the exam, then it really doesn't matter. Your calculator doesn't care. All right, so what's the height of this triangle? 6 newtons, right? So we went from 0 to 6 newtons. So the height would be 6 newtons. Okay. Multiplying those two, 1/2 base times height. So note that we get Newton meters, and a Newton meter is a joule. If you fail to convert millimeters to meters, you cannot get joules, right? A joule is a Newton meter. And so that's the units that we get here. So now for a little bit of button pushing, 0.5 times 30 times 10 to the negative 3 times 6 gives me 0.09. So choice A is correct. I hope. We always check the mark scheme and make sure we didn't make a mistake there. And I actually think I have it handy here. So this is question 20. We'll leave all that working up there for a moment. All right, and so always give yourself immediate feedback. Question 20, the correct answer was A. I think that's what we got, right? Yeah. So as you're practicing, you guys know where to find these practice questions. You know where to find the answer, but note that that's all they give you for paper 1. They don't explain anything. They don't tell you how to get to that answer. And so as you're working through it, do your best to come up with your own answer. Give yourself immediate feedback. And if you don't arrive at the correct answer, see if you can't sort of retro-engineer the question and go, oh, I see what I did wrong. I took the wrong sort of area. And that's a great way to study. And then bring any questions to class that you're still having questions about.